Welcome to the 46th lecture of Digital Electronics subject. In this lecture, we are going to deal with basics of full adder. In lecture number 45, we have dealt with half adder. In this lecture, we will be dealing with some basic concepts of full adder, that again taking into account the basics from half adder. So coming into full adder. Full adder is basically a 3-bit adder. If you are drawing the block diagram of a full adder, it has 3 inputs, say A, B and input carry. Outputs are sum and carry. So it has 3 inputs and 2 outputs. Here the sum is basically in decimal format. Sum is basically A plus B plus C. Okay. It is not OR, it is just A plus B plus C. Whereas carry you will take out from the sum by carry is taken by converting the sum in decimal form to binary form. For example, if you are having 3 numbers, say 0, 0, 0, if you are finding the sum 0 plus 0 plus 0, 0 and carry is also becoming 0. Another 3 numbers, 0 plus 1 plus 1. 0 plus 1 plus 1 is sum is 2. Okay. But actually what happens is that you cannot get 2 as output as sum, because sum is basically in digital format. Therefore, what I can say is that take the binary of 2. Binary of 2 is 1 0. Therefore, in 1 0, the sum is 0 and carry comes out as 1. Okay. So if you are taking the sum and carry part in digital format, it will come out as sum is 0 and carry is 1. Another example, if you are going for 1 plus 1 plus 1. 1 plus 1 plus 1, the sum is 3. What is the binary equivalent of 3? Binary equivalent of 3 is 1 1. So the last bit becomes the sum and the first bit becomes the carry. Therefore, here the sum is 1 and carry is 1. And this 1 and 1 forms the total result. That means this sum and carry in binary format. If you are converting to decimal format, you will get the exact answer. Okay. So that is the basic concept of full adder. Now coming into truth table of full adder. Truth table of full adder. We are having 3 inputs. A, B and C. There are 3 inputs, A, B and C. And there are only 2 outputs. Which are the outputs? Sum and carry. Okay. So you have different combinations. 1, 2, 3, 4. 1, 2, 3, 4. 0, 0, 1, 1. 0, 0, 1, 1. 0, 1. 0, 1, 0, 1, 0, 1. 0 plus 0 plus 0. Sum is 0, carry is 0. 0 plus 0 plus 1. Sum is 1, carry is 0. 0 plus 1 plus 0. Sum is 1, carry is 0. 0 plus 1 plus 1, it is 2. That means 2 is 1 0. 1 0 means sum is 0, carry is 1. 1 plus 0 plus 0, sum is 1, carry is 0. 1 plus 0 plus 1, again you will get 2, that is sum is 0, carry is 1. 1 plus 1 plus 0, that is sum is 2, that means sum is 0 and carry is 1. Now coming into 1 plus 1 plus 1, 1 plus 1 plus 1 is sum is 1 and carry is 1. Now let me write the decimal equivalence considering A, B and C. This is 0, 1, 2, 3, 4, 5, 6 and 7. Therefore, if you are writing the expressions, you should write the expressions in POS form as well as SOP form. Now coming into min-term expression, that is in SOP form. You should write for sum and carry. So what is sum? Sum is equal to sigma m. Where all you will get 1? You get 1. That is 1, 2, 1, 2, 4, 1, 2, 4 and 7. That is 1, 2, 4 and 7. Yeah. Now coming into carry part. This one. Okay. Now coming into carry part. Okay. Where you are getting 1 at 3, 5, 6 and 7. So that is sigma m 3, 5, 6 and 7. Okay. So that is regarding min term. Now coming into match terms. Coming into match term expressions. Okay. Coming into match term. Okay. Now, what is sum? Sum is equal to pi capital M of. Where you are getting zeros. Zeros are at and 1. Sorry, at 0, 3, 5, 6. So we will get it as 0, 3, 5 and 6. Okay. That is where we are getting the sum. Okay. Now, where we are getting the carry? Now coming into the carry part. Where we are getting the carry? Carry is equal to pi of, pi m. We get pi m. Carry we get as pi capital M. Where we are getting 0, 1, 2, 4. Yeah. This is where we are getting 0, 1, 2 and 4. That is where we are getting the carry. Okay. So now I have got the min term and max term expression of min term and max term expression of full adder. Okay. Now coming into this one. Coming into realization. Now coming into a realization of full adder. Realization of full adder. Okay. So here I will go with AND or inward logic, and going with XOR, and to get XOR. AOI means you are allowed to use only AND, OR and NOT gates. So take the min term expression for sum and carry. For min term, what is sum? Sum is equal to sigma m. What do you get? 1, 2, 4, 7. Sigma m 1, 2, 4, 7. Okay. Now if you are taking the sum If you are writing the expression of sum, what will you get? You will get it as say A, B, C. You will get 4 terms, or A, B, C, or A, B, C, or A, B, C. Okay. So 1 means it is 0, 0, 1. Okay. 2 means 0, 1, 0. 0, 1, 0. Yeah, that is A bar, B, C in bar. 4 means 1 double 0. 1 double, that is A, B bar, C in bar. 7 means A, B, C. Right? 4 means it is 1, 0, 0. That is A. Yeah. Okay. Now, if you are writing the, now see, you can take C in common from first and last terms. Therefore, you can write sum is equal to C in and A bar, B bar, or AB, or C in bar can be taken as common from second and third terms. From second and third terms, C in bar can be taken as common. So it is or C in bar and A bar B or AB bar. What is it basically? That is C in and this is A H nor B. A H nor B or C in bar and A H or B. Okay. Now, regarding sum, suppose I am taking A H or B. I am taking A H or B as say capital X. Then sum can be written as C in X bar or C in bar X. So this I can again write it as C in X or X. What is it? That is C in X or A X or B. Or I can write it as A X or B X or C. So that is the expression for sum. Sum is A X or B X or C. Now coming into carry part. What is carry? Carry is sigma m 3, 5, 6, 7. 3, 5, 6, 7. Okay. So how can I write it? That is A, B, C in. I will get 4 terms. A, B, C in or A, B, C in or A, B, C in or A, B, C in. Okay. 3 means it is 0, 1, 1. So that is A bar, B, C in. 5 means 1, 0, 1. That is A, B bar, C in. 6 means 1, 1, 0. That is A, B, C in bar. 7 means A, B, C in. Now see, here what we can take. In the last 2 terms, you can take A, B as common. And in the first 2 terms, you can take C in as common. So what do you get? You will get C in and A bar, B or A, B bar. Or A, B and C in bar or C in. What is C in bar or C in? C in bar or C in is 1. And what is this? A bar B or A, B bar is A H or B. That is C in and A H or B or A B. Okay. So that is basically the carry. Okay. So we will get the expression of sum as sum is A H or B H or C in and carry is C in and A H or B, C in and A H or B or A B. Okay. Now let me draw it with the help of this XOR gate. Okay. So first I am having A, B and C in. So sum is A XOR B XOR C in. So it is XOR gate. Okay. So this is A XOR B. Again that is given to an XOR gate. C in is coming in. So here what do we get? Sum. Sum is A XOR B XOR C in. Okay. Now coming into carry part. See, A XOR B is here. You should AND it with C in. Should AND with C in. Yeah. Okay. So you got the first term, that is Cin into A XOR B or A XOR B. Then next one is AB. So I am taking B here, A here. So this is basically AND gate AB, and if you are summing it or if you are making it into an OR gate, you will get the carry. This is realization using XOR gates. Okay. So here I have used XOR and AND gates only. Now coming into realization using AOI logic. Realization using AOI logic. Okay. For that, what is the sum? Sum is sigma m, or I will write in this form. So sum is equal to Cin H bar, or yeah, we have the expression of we have the expression of sum. Sum is A bar B bar C, or Cin. We will take this expression. Okay, Cin and A bar B bar or AB. 1, 2, 4, 7. So that is Cin and A bar B bar or AB, or Cin bar and A B bar or A bar B. So that is sum. Now what is carry? Carry is sigma m. Carry is sigma m 3, 5, 6, 7. Sigma m 3, 5, 6 and 7, that is equal to Cin and AB bar or A bar B or AB. So I need to realize this using AOI logic. Now let me come into the format of this AOI logic. So A is an input, B is another input, Cin is another input. Now here what you need? You need A bar, B bar as well as Cin bar. So I am taking A bar here. This is A bar. Now coming to B bar. This is B bar. Now coming to Cin. This is Cin bar. Now first term is A bar B bar. A bar B bar. So you got an AND gate. So this is A bar B bar. Now next term is AB. A B. This is AB. Okay. You OR that too. If I am ORing that too, you will get A bar B bar or AB. Okay. That is ANDed with Cin. That is ANDed with Cin. Okay. Now next one is AB bar or A bar B. So A is there. So this is A B bar. So this is A B bar. Then A bar B. A bar is here. A bar is here. B is here. So this is A bar B. A bar B. That two are odd. And that OR combination is ANDed with Cin bar. That OR combination is ANDed with Cin bar. Okay. So you got now you got what? Now you got these two terms. Okay. This term as well as this term. Now if you are making an OR of these two terms, so I am making an OR of these two terms. Here I will get the sum. Now, what is carry? Carry is AB bar or AB. AB bar or AB is already here. AB bar or AB is already here. Okay. Yeah. Then AB. Whether AB is there. Yeah. So this is AB. So AB is already here. So this is AB. Yeah. Now that is AB bar or A bar B, and with Cin. So Cin is here. I am ANDing it with Cin. I am ANDing with Cin. Okay, so you got the first term. Now next term is AB. AB is there. So now you should OR these two terms. I am ORing these two. There you will get the carry. Okay. So now I have realized this full adder using AND or invert logic. Okay. So I think you have got the concept. Okay. Now see, full adder consists of inputs A, B, C in, as well as outputs sum and carry. Now I think you have got the logic of full adder, a basic full adder. Okay. So to have a recap of the lecture. So basically a full adder is having three inputs A, B, C in. So if you are taking the sum is in decimal format, that is A plus B plus C in, and carry is obtained by converting it into binary. And what is basically sum and carry is also basically in binary format. Okay. So it is basically the binary writing. For example, if you are having 0 plus 1 plus 1 plus that is you will get 2. Sum is actually 2, but you should write it in binary form. So you will get 1 0. That means carry is 1 and sum is 0. So you should write in that form. Okay. Now again 1 plus 1 plus 1 is 3. So carry is 1 as well as sum is 1. Okay. So that is the basic concept of this full adder. Now after that I have drawn a truth table of full adder, highlighting all the sums and carries in zeros and ones form. Now obtained the min term and max term expressions, and from there derived the expression of sum. So the sum of a full adder is AX or BX or C in, and carry is basically C in and AX or B or AB. So I have realized it using basic XOR gates and AOI logic. Now if you are looking to this XOR gate combination, it is basically what? It is basically combination of two half adders. It is basically the combination of two half adders. So if you are taking these two, so I am taking like this. Okay, if I am taking a combination like this, here, yeah. Whatever is inside this green, that forms a half adder. Again, if you are taking another combination like a blue combination, this one violet. If I am going with the violet, if I am taking these two, so I am taking these two, that means one XOR gate and one AND gate, that forms the second half adder. Okay. So basically full adder is a combination of two half adders. It's a combination of two half adders, but connected in a specified fashion. That means output of the first half adder is given as input to the second half adder. Okay. So that is the basic concept of a full adder, and I have realized it using AOI logic. So with that I am ending with this lecture. In the next lecture we will deal with a realization of this full adder using NAND gate, and after that the lecture succeeding that we will deal with a realization of full adder using NOR gate. Thank you.